tell you the mass is 20 grams. They say the volume is 400 cubic centimeters. We don't work in cubic centimeters, we work in decimeters. So it's down 10 to the power negative 3. And then they say you have barium hydroxide. Let's see, what is the formula for barium hydroxide? Why? Say again. Barium is in group 2 on the periodic table. It is +2. Hydroxide is one of the 7 polyatomic ions that you must go study. It's -1. +2, -1, so that's why you need 2 of the negatives. Yes? This is something that you should know by now. Why do they give you that? So that you can determine the molar mass. Asina, what is the molar mass for barium hydroxide? Okay, the concentration is mass over molar mass times volume. It's 20 over 171 times 0.4, and that gives you what? Is it wrong? Joh, wie snyf so? Who needs toilet paper? Yes. What is it? 137, is it? Plus 2 times 17, and then 171. Say again. BA 56, number 56. And then hydroxide? Yes. Yes. Times 2. Yes, you are supposed to times it by 2. Yeah. Sabona. Do we need to write another test? Yes. This work? Okay, tomorrow. First period. I don't see you on Thursdays. Okay?
So ma'am, this one you don't show our parents' name.
No, you show your parents. No, you show your parents. We will see if you do better in the second one. I'll let the second one count.
Yes.
Everything.
Ma'am, even the definition.
No, I won't ask definitions. Okay. Right. Next one, B. Let me just write this down. See, yes. Okay. C. C, it says the mass is 10 grams of silver nitrate. Silver nitrate. Atlehang, what does silver nitrate look like? What is silver's symbol?
AG.
Yes. And nitrate?
It's bracket.
What's nitrate?
It's
Like that. That is nitrogen monoxide. Yes. And silver is +1. Nitrate is -1. So they fit perfectly. So it's just silver nitrate. Okay? What do they give you that for the molar mass? Karabo, what is the molar mass of silver nitrate? What's silver? 107. 108. What is it? 170, and they say the volume is 350 cubic centimeters. We don't work in cubic centimeters, we work in decimeters. So concentration, mass over molar mass times the volume. The mass is 10, molar mass is 170, 0.35, and trust, what do you get? Zero 0.1 117, and the unit? Mole per decimeters cubed. Okay, then D, they say there. What is the potassium ion concentration in the mass of 13.8 grams of potassium carbonate, and the volume is 250 milliliters? 250 milliliters. Do we work in milliliters? No, we work in. So how are you going to convert? Milliliters, I said this. Where did I say that? So I said milliliters is the same as centimeters cubed. Liters is the same as decimeters cubed. So how are you going to go from milliliters to liters? Did you make this note? Okay, so you're going to say times 10 to the power negative 3. And they give you that so that you can calculate the molar mass. Amara, what is the molar mass? Okay. Now, when we calculate the concentration here, Carabello, what concentration are we calculating? For the whole thing. So here we calculate the concentration for the whole molecule. Remember, the square brackets stands for concentration of. So concentration of the whole thing. And if you calculate that, what do you get, Rele? Okay, 0.4. But they did not ask for the whole thing. They asked for the concentration of just the potassium ion. So to me, what are you going to do? Wait. This thing we call the dissociation reaction. So it's not balancing the reaction. You write down the dissociation reaction. You show how it splits up. Okay, sorry, go continue. Yes, 1, 2. Yes. Mooi. Sharp. Okay, so on Thursday you write a chemistry test. 10 marks? Friday. You write a chemistry test on this chapter. Let's make it a bit. No, let's keep it 10 marks. 10 marks. Because I wanted to go quick. Because we need to continue with the work. Alright, so now we are at your next chapter. Your next chapter is physics. And your next chapter is what your practicals should be on. So we need to move fast so that we can do the practical. Okay. The next chapter is called vectors, and then it goes on into motion. Vectors and motion. Okay, now you remember from the beginning of the year, we did this conversion. Let's quickly go over them again. Let's start here in the middle. Now, I gave here meters, but remember it can be grams, it can be hertz, it can be seconds, it can be anything. So we have meters, 1,000 bigger is kilometers, 1,000 bigger is mega, then giga, then tera. If you go smaller, milli, micro, and micro needs to have like a little foot there. Micro, nano, pico. And then in between meters and millimeters, you have decimeters and centimeters. Where each jump here is 10, 10, 10. So together, 10 times 10 times 10 gives you 1,000. Sharp? Okay. Now, the first bit of this chapter is a lot of theory that you need to go study. In the physics world, we have two big concepts. Okay? We have scalars and vectors. Quick pause there while I remember. What did I want to do? Grote griet. Next week is Science Week. For Science Week, then the following will happen. Okay? On Monday at first break, I'm going to do experiment in class. Okay? Tuesday, there's going to be a Sudoku competition in class. So everything's happening at first break. So you come in, I give you the Sudoku paper, the first one to complete it and have it correct wins a prize. On Wednesday, so Monday, Tuesday, Wednesday, you can send WhatsApp me memes and jokes like this. And the one according to me that's the funniest will win 50 Rand. Then on Thursday, there will be a Kahoot competition. You know Kahoot? Competition in class. You must bring your cell phone with enough data, and then the winner there wins a prize. And then Friday, in the class, we will make a bomb if there's time. A bomb. But like not a bomb, it's a bomb. Yes? All science learners and everyone that wants to participate. No. All right. So why I'm saying this? I'm preparing you for the meme joke. Okay. So if you are on Instagram, TikTok, I don't know what you use, and you see a funny science joke that I can print out and put in class, you must send it to me. Sharp. As many as you can. There's the winners of 3 years ago. I couldn't choose between all of them. So there was the winners.
So you gave them each 50 Rand?
No, yes, I did actually give each of them 50 Rand. Good. That's why I do it once in 3-4 years. Alright. Okay, so in science world, in the physics world, we have two big concepts. Scalars and vectors. So we want to classify things. We want to put them in groups. Like we say, this is boys, this is girls. This is cold, this is warm. This is long, this is short. Okay? Same science world, we want to put into this is scalars, this is vectors. And what is a scalar? A scalar is a physical quantity. So mass, time, something like that. Physical quantity which only has size. Okay? For example, let's highlight. So scalar is a physical quantity which only has size. Now, in the science world, we either use the word size, but we prefer to use the word magnitude. Magnitude refers to size. Magnitude refers to size. Okay? So, for example, time. Okay? Can you go back in time? No. You can't say, okay, I'm going to go into negative time, so I'm just going to reverse a bit. You can't do that. So time is only size. Something is a day, something is an hour, something is tomorrow. Okay? 24 hours from now. So you could size, time only has size, it only has magnitude. The same as, let's look at energy. Okay? Yes, you can lose energy, but you can't go back into energy. I can't go, like, it's difficult to think, but I can't reverse energy. You either lose it or you gain it. Okay? So these things all are examples of scalar quantities. Okay? Because they only have size. Okay. So you need to know this. So I can ask something in a multiple choice question regarding this. Then I'm going to get to the definition of mass in a moment. Then we have vector quantities. That is something that is a physical quantity that has size and direction. Okay? So, for example, velocity. Velocity. You can move forward and you can move backwards. Yes? You can reverse, you can go forward, or you can reverse. Or if you look at force, I can apply a force to the left, or I can apply a force to the right, or I can apply a force up or down, or north or south. You with me? So these things all have size and direction. Okay, now, when we look at mass and weight. Mass and weight. Mass refers to the quantity of matter something consists of. How many particles do you have? Like if I were to take you apart, how many atoms, molecules, ions, and do you have in your body? So it is the quantity. Quantity refers to how much. Quantity refers to how much. The quantity of matter something consists of. How many particles? And we measure that in kilograms. Whereas weight is the size of the gravitational force or the gravitational pull on an object exerted towards the center of the earth or towards the center of the planet or the moon. Okay, and that is measured in newtons. So if someone asks you, oh, how much do you weigh? They're actually asking it wrong. They're not asking your newtons. If someone asks you, what do you weigh? Do you give it in newtons? Then you give it in kilograms. You'll say, I weigh 80 kilograms. Okay? So they should actually ask you, what is your mass? Right? Now, when you go to the moon and you need to walk on the moon, explain what does that look like. When you go to the moon and you walk on the moon, what will that look like? Have you seen videos of people on the moon? Yes. Do they just walk like this?
No.
What does it look like? They float. Why do they float? Gravitational force. We walk on the surface of the earth because the earth has a certain weight, the earth has a certain radius, and because of that there's a certain pull, and we stay on the earth. We jump, we come back down because of the gravitational pull. The moon does not have the same pull. Okay? So that's why you float on the moon. Yes. Now, my question please. Will your mass be the same on the moon as it is on the earth? Look at the definition. What is mass? It's the quantity of matter something consists of. When you go to the moon, did you lose an arm or a leg or a head? No. On the moon, hopefully, on your way there, you did not lose anything. Okay? So your kilograms on the moon will be exactly the same as it is on the earth. But your weight will be different because of the pull on the force, on the moon is different. Are you with me? So this is a multiple choice type of question. I'll say, on the Earth, your mass is 50 kilogram. What is different on the Moon? Then I'll give you the option. Mass, weight, size, and I'll make up something, time. Okay, then what is different on the Moon? Your weight is different. Why is it different? Because of the gravitational force. Or I'll ask you a multiple choice question. On Earth, your mass is 50 kilograms. What is your mass on the Moon? Then I'll give you an option. A, 50, B, 50, B, 500, C, 50 times 10, D, 50 times 9.8. What will your mass on the Moon be? A. Okay, you get the idea? Yes. Right, then I want to go to force. What is force? So here there's definitions. Please be aware, those are definitions. Okay, what is force? Force is a push or a pull that can deform an object or change its state of motion. See where? What does the word motion refer to? Change its state of motion. Motion, yes. Movement, yes. So if I look here at trust, this is an object. If I apply a force on trust, I can either be stationary, I can apply force, I can make him move. Or if he's moving, I can cause him to stop. I can deform him. So if I punch him, I can deform his face. Okay, so when I apply a force, I'm either changing his shape, or I'm changing his state of motion, or doing both. Okay, so that is the definition of a force. Now, we are specifically in this chapter going to look at a lot of vectors. Now, how do we represent a vector? How do we show a vector when we draw it or talk about it or something like that? Okay, a vector is always, so I'm here with a vectors. A vector is represented by a solid line, straight line, according to a scale. So if it is 10 centimeters, it represents 10 newtons, for example. So scale in a specific direction, and that direction is represented with an arrowhead. Okay, so when I have a vector, I showed with a line, solid line, with an arrow at the end. Okay, or a line with an arrow like that. Okay, anyone? Ooh, I forgot to tell you, to warn you. You are going to need a compass and a protractor. I have a few that you can borrow in the meantime. Okay, let's see. Oh, before I say this, in mathematics, right, you have had, now I must remember correctly, you have had 0, 90, 180, no. You had 0, 90, 180, 270? Yes? This is not mathematics. Okay? We are working with the rules of aviation. Aviation? What in this world, Atlehang, is aviation? Yes. Yes, you can. A dictionary. Yes. No. Well, yes, science, but no. Okay, right. So we work with a dotted line like this, and the north line there is our 0 degree line. And then we go clockwise from there. Then we have 90 for east, south is 180, and west is 270, and then that is obviously 360 again.
Remember, aviation is looking for directions.
Huh?
It's for directions.
For what?
For directions.
No. Your sister already said the answer, but I'm not going to say that out loud because too many searching. Okay. Aviation. What does it say?
So when it says an art of flying aircraft.
Aircraft. So it has to do with airplanes. Okay, so what they use in airplanes. Right, now I want everyone to close your eyes and show me with your fingers where is north.
Just in general, like.
There's only one north. It's not relative. There's one north. Close your eyes, show me where's north. Open your eyes. Absolutely no one is correct. North is not up. North is not in front of you. It's not there, it's there. There's north. Where does the sun come up? In there?
No.
No! East. Sun comes up in the east, sun comes up there. Where does it go down? There. Where's north? In between. There's north. There's only one north.
When you wake up, don't look where the sun is.
Yeah.
We just.
You don't look where the sun goes down.
No.
You should.
Why?
But you should be specific. You should be specific, like not of what.
Who takes geography? You should know this. Where is north?
Where is north?
North is there, people. There.
Yes, ma'am.
Always think, where does the sun come up? If you are lost and you don't have yourself and your battery is dead, how the hell are you going to know where you should go?
But they say that like they build houses facing north, and some of the houses are
Facing that
that
way.
side.
Yes, ma'am.
That house is not probably built.